Hello everyone, this is the Homework 7 in Alex with Math 1111. So number 1, we see that we're asked for each relation, we have to decide whether or not it's a function. So you can think of functions this way. The things on the left are maybe people, the domain, and the range could be ages. One person cannot be two separate ages, but 2 or 3 people could be the same age. So let's take a look at this. The first, relation 1, tells us that moon is 2 and -7. That can't happen. Moon cannot be 2 things, so this is not a function. Our relation 2 tells us that 6 is -7, 6 is also 0, and 6 is 6. 6 cannot map to 3 different things, so this is not a function. Relation 3, you basically don't want any duplicates in your x's, because that means it's trying to map to something more than once. In relation 3, each of our x's, remember it's x, y in an ordered pair. So each of our x's are different, so this is a function. Looking at relation 4, we have -6 for an x, 3, 4, and again -6. This one says -6 is going to be h. This one says -6 is also f. Can't be both of them. That's not a function. Remember, you can pause these videos if I get to going too fast. So, being able to look at the mappings, which is what relation 1 and 2 are, and being able to look at the ordered pairs, as relation 3 and 4 are, to decide if something's a function, we also can look at the graphs to decide if something is a function. And remember, you can't have 2 y's for the same x. So if we were to draw a vertical line on this first graph, we cross 2 points. So it says that when x is 0, you have the point 2. You also have the point 0, 4, -4. Also over here, you cross 2 points on a vertical line. So this is not a function. There's 2 y's for one x value. It's called the vertical line test. All right, so if we try this graph 2, we only cross 1 dot when we draw the vertical line test. So yes, this is a function. On graph 3, while it's true if you were to draw the vertical line there, it would only touch one place, but it's not the same thing on every part of the graph. We touch 2 places there with a vertical line, so this is not a function. But you can guess graph 4, huh? We can draw a vertical line and touch 2 places, so that's not a function. Graph 5, drawing that vertical line, I only touch 1 place, so yes, that is a function. Graph 6 can be tricky, and you have to watch out very carefully. There's a gap here, so I don't have to worry about that. The only place there's an issue might be right here where these 2 open point and closed points are in line with each other. But because that is an open point at the top, it's not, our line really isn't touching that point. It's open. Our line is only touching that point there. So yes, this is a function. Now we start learning about a little more about function notation and inserting different things into the functions. My earpiece just hit the lamp and I didn't know what was attacking me. All right, so in our first function, it's called f of x equals negative 2 x cubed minus 5. And they want us to take and put the negative 2, f of negative 2, put the negative 2 in for x. So f of negative 2 equals the negative 2 that's originally in the problem times the x, which is the negative 2 they're telling us to put in, negative 2 cubed minus 5. Now it's just arithmetic. So negative 2 cubed is negative 8 minus 5. Negative 2 times negative 8 is negative 16 minus 5. So this is, whoops, watch out. Negative times a negative makes positive. So this is 11 for our f of negative 2. The next piece, we have the function g of x equals negative 5x plus 4. So they want us to put the 3 in where the x is. So g of 3 is negative 5 times the 3 plus the 4. Negative 5 times 3 is negative 15 plus 4. Negative 15 plus 4 is negative 11. Feel free to pause and work these problems out. All right, so our next problem, same idea, only this time our function is a rational function because it's a fraction. F of x equals 3x in the numerator, 2x minus 18 in the denominator. This time they want us to put the 7 in for each of the x's. So f of 7 equals, in the numerator, 3 times 7. In the denominator, 2 times 7 minus 18. So the numerator is 3 times 7, which is 21. Denominator, 2 times 7 is 14, minus the 18. Our numerator is still 21. Our denominator is 14 minus 18, which is negative 4. They don't like negatives in the denominator, remember, so we make it negative 21 over 4 for our answer. Now this next problem is really long, so we're going to kind of start here at the top, work our way down. We're given 3 functions this time, f, g, and h, and we're given 3 x values to plug into those functions. So f of x equals x in the numerator and x squared plus 12 in the denominator. That's our f of x. So they want us to take negative 4, f of negative 4, and that means we're going to take that negative 4 and plug it in where we have x. So I'm going to work this problem here at the top so we have room. F of negative 4 is going to equal negative 4 in the numerator, replacing that x, and then negative 4 squared plus 12 in the denominator. Notice the negative 4 in the denominator I put in parentheses because you're squaring that whole negative 4. All right, so the numerator stays negative 4. Denominator, negative 4 squared is 16 plus the 12. So the numerator is still negative 4. Denominator is 16 plus 12, which is 28. We can simplify that, bring the negative out front. 4 and 28 are both divisible by 4, so that simplifies to 1/7. Negative 1/7 then is your answer. Our next piece is g of x, our next function. G of x is the absolute value of 12x minus 10. Remember, the absolute value just wants us to find how far is a number from 0? So basically, if you get a negative inside the absolute values, just drop the negative to show that it's that many spaces from 0. Anyways, here we go. G of negative 2/3. So we're going to take that negative 2/3 and put it in for x. We're going to do this right here. G of negative 2/3 equals absolute value of 12 times the negative 2/3. Close the absolute value, minus 10. All right. So that's going to be the absolute value. Now you can remember 12 is over 1. And you can do this by 12 divided by 3, which is 4, times 2, which is 8. So we have a negative 8 inside our absolute values. Or you can do 12 times the 2 and get 24, divide by 3. Still get the 8 negative inside the absolute value. Minus 10. Well, the absolute value of negative 8 is 8 minus 10, and that gives us an answer of negative 2. Then the last piece is h of 2. So our h function, is kind of hidden over here where I've been writing, is the square root of 5x plus 13. So if we want to find h of 2, we're going to take the 2, plug it in for that x beside the 5. H of 2 equals the square root of 5 times 2 plus 13. Well, 5 times 2 is 10, so we have the square root of 10 plus 13. 10 plus 13 is 23. So we have the square root of 23. Let me write that over here. 23 is prime. There's no numbers that you can multiply together, whole numbers, that you can multiply together that will give you 23. So the square root of 23 is where we end up. Question 6 is just like what we've been doing. Instead of just putting a number in for our x, they're going to want us to use a 2x. So our function is h of x equals, numerator is 3 plus 3x, denominator is negative 2 plus x. So they want us to take that 2x and plug it in for each of these x's. So h of 2x equals 3 plus 3 times 2x over negative 2 plus 2x. You can put that in parentheses so you remind yourself what's being substituted for your x in case you need to go back and check yourself. So in the numerator, we're going to have 3 plus 3 times 2x is 6x over the denominator, which is negative 2 plus 2x. You can factor out some common terms, but it's not going to do anything to help you simplify that. So that's as simple as it's going to get. So we'll just kind of do this so we'll know that's that problem. Because we can do domain and range over here. We're good with domain and range. So domain is your x values. Range is your y values. And remember that your ordered pairs are written x, y. All right. So looking at your domain, you're just reading the x values. And we'll put it in a curly brace to signify set notation. It's the set of negative 1, that's your x, 9, that's your x, and negative 9. And then we'll close it with the closing curly brace. For range, just read the y values. Now domain and range come in really important, very, very important in your next class, 11-13, and into the calculus sequences and all the future math classes you take. So the range is the same thing. We're going to use a curly brace to signify set, so I can't draw those too well. And we're going to just read the y values. Now we notice with the y values we got two 5s, okay? We only have to write the 5 down once. And then a 0. That's your other y. And that's your range. Question number 8. We have the function g defined as g of x equals, numerator is x minus 9, denominator is x squared minus 4x minus 5. And they want us to find all the values of x that are not in the domain. All right, if there's more than one, separate with commas, of course. So basically you need to remember that the denominator cannot equal 0. So all we do is we set x squared minus 4x minus 5 not equal to 0. And we can factor this. Remember, we want the factors of 5. That subtract to 4. Well, 5 and 1 subtract to 4. And multiply to 5. Remember, factors mean multiplication. We want a minus 4. So it has to be a minus 4, 5, and a plus 1. So set each one of these not equal to 0 is kind of like an inequality. These values can be everything except these values. These are the ones that are not in the domain. So this one says x not 5, and this one says x is not negative 1. So our solution is 5, comma, negative 1. Those are the numbers that cannot be in the domain of G. In fact, question 9 is the exact same question. We get to factor some more. Yay! So the functions f and g are defined as follows. F of x equals x plus 3 divided by, and that's the numerator. Denominator is x squared minus 6x plus 9. We want to find the domain. So again, the denominator cannot be, cannot be 0. So x squared minus 6x plus 9, it's not going to be 0. Factor that. Oh, look, it's a perfect square trinomial, right? Factors of 9 that give you 6, simply x minus 3, and x minus 3 again. Take the square root of both sides. This tells us x minus 3 is not equal to 0, so x is not equal to 3. So 3 is going to be one of our answers. Okay, this time we're finding the domain. Read the instructions. My professor always said, read the instructions. This answer is going to be written in interval notation. Okay, so x is not going to be 3. So draw our little line here. We simply have a hole at 3. X can be everything else but that 3. So x, starting out here at negative infinity, going to infinity, but it can't be 3. So we have negative infinity. Oops, that's not going to go there. Negative infinity to 3, union 3 to infinity. Let me make this look more like a parenthesis. There we go. That's the first piece. Second one is g of x equals numerator is x minus 4. Denominator is x squared minus 16. So again, we're just going to set that denominator not equal to 0. So x squared minus 16 not equal to 0. There's two ways to do this. You can factor it, right? Difference of squares. X minus 4, x plus 4 not equal to 0. You could add the 16 to both sides and take the square root property. It's your choice. Get the same answer at the end. All right, we're going to set each one of these equal to 0. So x is not equal to 4, and x is not equal to negative 4. So we'll draw our number line. Negative 4 is here, 4 is here. This is where it's open, and it's everything else. So we're starting at negative infinity, going to negative 4, all open, union, negative 4 to 4, union 4 to infinity. Yes. There we go. And that is our interval notation. Notice, if you had 1 point, that was our excluded value. You had a u. If you had 2 of them, you had 2 u's. It follows like that. Yay! Domain is hugely important, so that's why we get to do so much domain work here. Again, we're going to find the domain, and we're going to use interval notation. With square roots, we just have to remember that the part underneath, 7 minus x, has to be greater than or equal to 0. But we can subtract the 7 from both sides, and we get minus x is greater than or equal to negative 7. Divide by negative 1. Remember, we talked about that. Change the sign around. X is less than or equal to 7. So that is negative infinity to 7. 7 is closed this time. And there's our interval. Yay! So the next one is also find the domain. Write the answer as a union or an interval of unions. We have 2 problems in this one. It says f of x equals, the numerator is the square root of x plus 4, and the denominator is 2x minus 5. The numerator, we just learned that the x plus 4 has to be greater than or equal to 0. And from above, we learned that the denominator, 2x minus 5, cannot be 0. So we have 2 things to solve out here. X plus 4 has to be greater than or equal to 0. We got to solve 2x minus 5 cannot be 0. Well, we got our algebra down. Subtract 4 from both sides, and we know that x is greater than or equal to negative 4. So negative 4 is there. Greater than or equal to is solid dot, and shade everything to the right. 2x minus 5 is not equal to 0. Add 5 to both sides. Divide by 2. It's a fraction. Yay! So we have a whole at 5 halves. 5 halves is about 2 1/2, right? So this is about 5 halves right here, and there's a open hole. So our interval notation then, it would start from negative 4, go to 5 halves, that's open, remember, union the 5 halves. Remember, 1 excluded value sometimes gives you 1 union, and this is going to infinity. Isn't this fun? Oh, goody, a word problem. I know how much you all love these. All right, Keisha wants to save $800 to buy a TV. She saves $19 each week. The amount A in dollars that she still needs after W weeks is given by the following function. A of W equals 800 minus 19W. Okay, so I like to reread a problem after I've started reading it once. Keisha wants to save $800 to buy a TV. She saves 19 each week. A is the dollars that she still needs, and W is the weeks. They gave us the formula already, so we don't have to figure that out yet. We have 2 questions to answer. How much money does Keisha still need after 5 weeks? So in part A, they're giving us the weeks. They're giving us, this is the W. W is going to be 5. So we just have to figure out A of 5, which is 800 minus 19 times 5. That's going to be 800 minus 19 times 5 is 95. Get your calculators and check me. 800 minus 95 is 705. So it's $705 that Keisha will have to still need after 5 weeks. Part B tells us if Keisha still needs 458, how many weeks? All right, so 458 is our A. And we want to search for W. So we take 458 equals 800 minus 19W. Well, this is our fun algebra problems, right? There's several ways to do this. We can add the 19W to both sides. I like to do that to keep my W's positive. It's a personal preference of mine. You could have subtracted the 18 and then divided by the negative 19. Now we'll subtract the 458 from both sides. Let's see, I think I need to do that because I'm going to have to doing all this math in my mind. This is what you should be doing, right? Because the final exam has no calculator. All right, so 800 minus 458, that's a 2, that's a 4, that's a 3. Oh, goody, now we get to divide by 19. You know what's fun? Let me show you how to do long division by hand. 19 divides 342. Well, it looks like it might go in there twice. Let's try 2. Well, let's see. Check it over here. 19 times 2, that's 18. No, that's 38. It won't go 2 times. All right, let's just say 1 then. 19. 34 minus 19 is 15. Bring down the 2. Alrighty, that's a big number. Since 19 is almost 20, let's divide 15 by 2. We get 7. So let's try 19 times 7. That's 63. 7 and 6 is 13. That might be too small. Let's try 8. 19 times 8. That's 72. 8 and 7 is 15. Yes, so 8 works. It's 152. And there we are. 18 is our answer. So the answer is 18 weeks. Alrighty, math is our friend. I'll go ahead and circle those for you. The red one go. Here we go. There we go. Yay! So if you haven't practiced long division by hand in a while, you might want to work on that. Alrighty, the next one, question 13. We have the function f. The graph of a function f is shown below. It's a parabola. Find one value of x for which f of x equals -4, and find f of 2. All right, so when f of x is -4, this is your y value. This tells you that y equals, hang on, f of x equals -4 tells you that y equals -4, and they're asking you to find x. It says we only need one value of x, because when y is -4, well, when y is -4, That's the only place it crosses. The x that and y is -4. So x. So therefore, x equals 0 because it's right on the axis, right? All right, that's the first piece. When we see find f of 2, that means that already gives us find f of 2 tells us x equals 2, and they're asking us to find the y. So therefore, we'll look for when x is 2. Whoops, took too many stray marks on there. When x is 2, and go down till you find where the 2 and the line make, and we see that -2 is our y. So that's what they're looking for there. More domain and range. Hugely important again, like I keep telling you. That's why we do so much of it. We have a graph of the function h. We want to find the domain, and what's the last color I used? Blue. So range. All right. Remember, your domain is your x values, and your range is your y values. So we're going to find out where this thing starts on the x-axis. It starts at -4. And if we were to take a car and follow this road or this line, we see that it ends at 2. So the domain, notice your open and closed pieces. Domain is supposed to be is the interval. Notice interval notation. Closed -4, open 2. Now, when we're looking for the range, we're looking at the y values. So we start at the lowest bottom point, because we can always read the smallest to the largest. So it starts at -3. We follow this road all the way up to the y value of 5. And -3 is closed, and 5 is open. Yay! Question 15 makes it just a little more exciting. Domain again, remember those are your x values. Range is the y values. They still want us to use intervals or a union of intervals. Watch out, there will be some of those. Because notice, for the domain, we start at -4, and we go to -2, and we got this little gap, and we're going to start again at -1 and go to 4. So we have a union on this one. So notice where your open and closed points are. We're closed at -4. Then that line rides all the way to -2, and that's open. Then it jumps from -2 to -1, open, and then goes to 4, open. Range is the y values. So we got this -5 where we're starting, and this line goes up to 1, but notice this line over here on the left just keeps going to 3. So because these kind of overlap, and in the old days we would just turn our paper sideways, which I can't do here, don't think. Nope. Not easily anyways. So we would turn our paper sideways so that the negatives were on the left and the positives were on the right, and we could see that the left line in this case, and the right line, they overlap. So you start where it starts and you end where it ends. It's kind of like an OR. So the range, and it's open at -5, and it's closed at 3. Might want to pause that and study that a little better. All right. The graph of a quadratic function, with vertex 3, -2. Vertex 3, -2, that's that point right there. In this particular one, it's the very, very top. If it's a right side up parabola, it's the very, very bottom, but that is the 3, -2 point. It is shown in the figure below. Again, we want to find the domain and the range, remembering that the domain is the x values and the range is the y values. Here's a hint. If it's a regular old parabola, the domain is always -infinity to infinity. All right? Because as these are getting further down, they're getting wider and wider and wider. So the x values are actually starting way out at -infinity, and they're going to infinity. The range has that same idea. Starting way down in the negatives, and way down in the negatives is -infinity. And it's coming up, and it's stopping right there at our vertex, which the y value is -2. And that's closed because there's not an open hole there. There's no open hole. So it goes all the way to that point. And that's all there is to that. Let me know if you need any help. Oh, we get to do another word problem. Domain and range, yay. Be careful, they interchange domain and range in your answer area. Sometimes domain's the first one they ask you for, sometimes it's range. Diane wanted to study how the area of a rectangle changes with the length of its width is fixed. Let's try that again. Diane wanted to study how the area of a rectangle changes with the length if its width is fixed. She computed the areas of several rectangles that have the same width and different lengths. She then plotted the results and connected them with a line as shown below. The graph shows the area in square millimeters versus the length in millimeters. Find the range and domain of the function. All right, so we want the range. Sorry about that. And they want the domain. I'm going to do a blue domain this time, since the line is black. Just remembering, domain is your x values, and range is your y values. So for the domain, I know they asked for range first, but it doesn't matter what order you do them in, as long as you just get the right answer. And we want to write our answers as inequalities using x or y as appropriate. So watch out for that. We also have empty set and all reals if it's possible. Not the empty set, right? I can see a line. It's not all reals because down here at 0 is a solid dot. So that means whatever's happening with the domain, it is starting at 0 and it's growing. So in the interval notation, domain on our interval notation would be from 0 to infinity. 0 included. Turning that back into set notation using x, that's x is greater than or equal to 0. If you need a visual for that, let me do a visual. So if you were to graph this line just straight, it'd be from 0 closed all the way this way, which we know is x is greater than or equal to 0. So that's our domain. I'm not going to bother writing it down here. Our range, same idea. You're starting here. This time you're going forever up. So the range is also going from 0 to infinity. Careful, sometimes those aren't arrows, those are dots. So be careful, if it's an arrow, it's going to infinity. If it's a dot, it's stopping where the dot is. We graph this, well, it's the same graph, right? 0 to infinity, which is y in this case, greater than or equal to 0. So that's what they're looking for in that one. All right, well, that concludes the lecture on homework 7. Thank you all for coming and listening. And homework, if you have any questions during the homework, you just let me know.